Now in this question we're being asked to compare two possible buffer situations where we're told that hydrogen carbon plays a major role in the pH of blood plasma. We're given one scenario where is H2CO3, HCO3 minus with a Ka of 6.38, and a separate one where it's 10.32. And we're told the pH of the blood is 7.4, and we're going to show which one is more significant at this pH in terms of its ability to buffer against added acid and base. Now obviously what that means is we're going to be using, you can use the log expression, but in this case I've just used Ka, and 7.4 is going to be a constant that can just go straight into there. And given the pKa here, we can obviously turn that into a Ka and put it there, and then make a comparison of these two numbers in terms of a ratio, and then do the same for 10.32 and work out an answer, and that's what we'll proceed to do. Now if we just do some calculations here and just turn this number into a Ka, this number into a Ka, and just converting that into a hydrogen ion concentration, we can work some things out using this formula right here. So that's what we'll go do. Okay, so if we do this as a comparison, the 4.16 for this pair, we end up with 10.45. And what that means is that for this number up here, if we kind of saying this is 10.45 units of base compared to 1 unit of HA, so to speak, and the base in this case is HCO3 minus, and the acid is H2CO3. So obviously in this case this would be much better at buffering if it's a base, the addition of an acid, and not so good at buffering the addition of a base because there's not that much acid present. That's that one. Now in this one, the second buffer pair, we get 1.2 times 10 to the negative 3, and what that means is that for every one of these you've got, or what I should say, for every 12 of these you've got something like 10,000 of these. So you've got very little base in this case, but a lot of acid. So when we look at this in terms of what we have up here, for this pair, that means there's going to be very little of that, but sorry, a lot of the acid here, but very little of the base present. So this is going to be much better at buffering the addition of a base because there's so much acid present. That's that one there, which is the same as HCO3 minus in this case. Now this isn't a matter of which has got the most, it's about having a balance. So neither of these are great, but this one here with so little conjugate base present would not be very good for a buffer. So the first one is the one that we would go for because it offers more of a balance in terms of there's better number, the ratio is better in terms of the amount of acid and conjugate base. Okay, and you need them present in some significant amounts. This is just too little here, and that's that question answered. Obviously when I finish this, you would do the calculations and give an explanation as well. Okay.